Scientists have recently discovered a new water reservoir on the moon that could change everything we know about our nearest neighbor in space. In this video, we'll explore how they found it, what it means for future missions, and how much water there is on the moon. Stay tuned to find out more. Please give this video a thumbs up and subscribe to this channel for more videos before we proceed. Click the bell icon to receive notifications of new videos. Have you already done this? Let's start. Discovery of the water reservoir. It all started with Chang'e 5 mission, which was launched in November 2021. The mission's goal was to collect and return lunar samples from a region called Oceanus Procellarum, which is a vast, dark area on the near side of the moon. This region is thought to be the youngest terrain on the moon and has never been sampled before by any other mission. The Chang'e 5 lander touched down near Mount Rümker, a large volcanic formation that arises about a mile above the lunar surface. It used a robotic arm to scoop up about 4 pounds of lunar soil and rocks and sent them to an orbiter that was waiting above. The orbiter then brought them back to Earth in December 2021, making China the third country after the US and the Soviet Union to successfully return lunar samples. The analysis of these samples revealed some surprising results. The scientists found that some of them contained impact glass beads, which are small grains of different colored glass that formed at high temperatures when an asteroid or a comet hit the moon. These glass beads are likely tiny time capsules that preserve information about the conditions of the impact in the environment at that time. What's more, these glass beads also contain small amounts of water molecules inside them. This means that there is a hidden water reservoir on the moon's surface that consists of these impact glass beads that were scattered by ancient collisions. The researchers estimate that there could be up to 270 billion tons of water stored in these beads across the moon. That's enough water to fill over 100 million Olympic-sized swimming pools. What does this mean for future expeditions? First of all, it sheds new light on the origin and evolution of lunar water. Until now, it was not clear how water got to the moon and where it was stored. Some possible sources of lunar water include solar wind implantation, which is when hydrogen atoms from the sun interact with oxygen atoms in lunar minerals; outgassing of volatiles during lunar volcanism, which is when gases like water vapor escape from volcanic eruptions; deposition of volatile-bearing pyroclastic deposits in minerals, which are rocks that contain water or other substances that can evaporate; and delivery by impacts of comets and asteroids, which are icy bodies that can bring water to the moon when they crash into it. The impact glass beads suggest that at least some of the lunar water came from comets and asteroids that hit the moon millions or billions of years ago. Secondly, this discovery also has important implications for future lunar exploration and colonization. Lunar surface water has attracted much attention because it could be used for in-situ resource utilization by future missions and settlers. In-situ resource utilization means using local resources instead of bringing everything from Earth, which can save money, time, and space. For example, lunar water could be used for drinking, growing plants, cooling equipment, making oxygen for breathing, and producing rocket fuel by splitting it into hydrogen and oxygen. Having a ready supply of water on the moon would make it easier and cheaper to establish a permanent human presence there. How much water is there on the moon? Well, that's not an easy question to answer, because different methods of measuring water give different results. For instance, if we only count the water ice that has been detected in the cold and dark craters at the poles, we get a relatively low estimate of about 600 million tons. That's about 240 Olympic-sized swimming pools per crater. However, if we include the water molecules that are bound to the minerals or trapped in glass beads all over the moon's surface, we get a much higher estimate of about 1 trillion tons. That's about 400 million Olympic-sized swimming pools spread across the moon. And if we also include the water that may be hidden deep inside the moon's mantle or core, we get an even higher estimate of about 100 trillion tons. Could we live on the moon by simply using the existing water reservoir? First of all, not all of the lunar water is accessible or usable. The water ice at the poles is buried under layers of dust and rocks that would require digging or drilling to reach. The water molecules on the sunlit surface are very sparse and scattered, which would require collecting and concentrating them. The water inside the moon is too deep and too hot to extract. And even if we could access all these sources of water, we would still need to purify them from contaminants like dust, minerals, or chemicals. Secondly, not all of the lunar water is renewable or sustainable. The water ice at the poles is constantly being eroded by micrometeorites and solar wind that can vaporize it or blow it away. The water molecules on the sunlit surface are constantly being broken down by sunlight, which can split them into hydrogen and oxygen that can escape into space. Living on the moon by simply using the existing water reservoir is not a realistic option. We would need to develop advanced technologies and strategies to access, purify, store, transport, use, and recycle lunar water in a smart, sustainable way. How is water possible on the moon? After all, the moon is supposed to be a dry and barren place. As we have seen, there are several ways that water can get to the moon and stay there. But how does that work? How can water survive in such a harsh environment? Let's take a closer look at some of the factors that make lunar water possible. First of all, let's talk about temperature. The moon has no atmosphere to regulate its temperature, so it experiences extreme variations depending on where and when you are. On average, the temperature on the moon ranges from negative 279 degrees Fahrenheit at night to 261 degrees Fahrenheit during the day. However, some places on the moon are colder or hotter than others. For example, the poles are colder than the equator because they receive less sunlight throughout the year, and some craters are colder than others because they are permanently shadowed by their walls or nearby mountains. These craters can reach temperatures as low as negative 387 degrees Fahrenheit, which is cold enough to preserve water ice for billions of years. Secondly, let's talk about pressure. The moon has very little gravity compared to Earth, so it cannot hold onto a thick atmosphere like ours. Instead, it has a very thin layer of gas called an exosphere that barely exerts any pressure on the surface. This means that any liquid water on the moon would quickly boil away into vapor due to low pressure. However, some water molecules can remain on the surface as solid ice or bound to minerals or glass beads. These molecules can form weak bonds with each other or with other substances that prevent them from escaping into space. Thirdly, let's talk about radiation. The moon is constantly bombarded by energetic particles from the sun and cosmic rays from outer space. These particles can break down water molecules into hydrogen and oxygen atoms that can then fly away into space. However, some water molecules can resist this process by hiding in places where they are shielded from radiation. For example, some craters have magnetic fields that deflect solar wind particles away from their interiors. And some minerals or glass beads have chemical structures that protect water molecules from being split apart. So there you have it. Researchers have found a new water reservoir on the moon's surface that could change our understanding of lunar history and our future plans for exploring and colonizing the moon. This discovery also raises many questions about how water behaves on the moon and how we can use it for our benefit. Today's video has come to an end. Remember to give this video a thumbs up and subscribe to the channel to view more content. Remember to click the bell symbol to receive notifications when new videos are posted. I will leave you with this and hope to see you in the next video.